Hey Ravens, we're going to talk about metabolism standard 2. Systems in the body work together to take in, break down, and deliver needed molecules to the cells. We talked about 3 major body systems in this unit. They were the circulatory system with the heart and your blood. We talked about the respiratory system, the lungs and the mouth. And we also talked about the digestive system, right? Where all those things were broken down. Hey, I'm going to show you a scary document. Don't freak out. Oh, so scary. It's not that scary. Hey, this is what we were supposed to teach you, right? And I just want to look at this one thing. Model how molecules travel through the body using the classroom body systems model. So remember when we ran around the classroom. Well, some of you ran, some of you didn't. We were, hey, look, here's a picture. This is Miss White's room. We moved around the classroom. Some of you were red blood cells moving glucose and oxygen. Some of you were a brain cell. Some of you were leg cells. Some of you were an arm cell. Some of you were the digestive system breaking down those very hard pipe cleaners. Some of you were the respiratory system taking in that oxygen. Hey, all 3 of the body systems had to work together to be successful in delivering those molecules to the cells. That has to do with our key concept. In a functioning human body, body systems work together to deliver glucose, oxygen, and amino acid molecules to the cells in the body. Right? Those systems can work together to form a larger, more complex system. Hey, that's you. You're a complex system. And a problem with the body system result in fewer oxygen, glucose, and or amino acid molecules getting to those body cells, right? We figured out that Elisa had diabetes, and that was why her body was not getting those glucose molecules to her cells. So in the sim, right, we see that we have these different body systems working together. We have the circulatory system moving glucose, oxygen, and amino acids around. And also we're going to have some of that carbon dioxide that's trying to get out. In the digestive system, we're going to have molecules of starch and molecules of protein being broken down into that glucose and into that those amino acids. Oh, I'm hungry. I'm going to eat a sandwich. It gets broken down, right, and then gets moved into the digestive system. And then we also have the respiratory system, right, bringing in oxygen, moving out carbon dioxide. Now, in the cells in the body, we have, right, all those molecules are getting to the cells because of all those systems are working together. Now, if we had a problem with one of the body systems, we would not be getting all of these necessary molecules to the cells in the body. All right, let's talk about a question that was on the critical juncture, right? We have, this question is one of the multiple choice questions. We have R. Frost, A. Kim, and V. Mystery. And we have all this data here, and it's like, oh gosh, this is confusing. I should just give up. Don't give up, okay? It's not that confusing. We just have to read through it carefully. We have a mouth, small intestine, and lungs, all part of the 3 systems, right? And we have 3 different molecules that we're looking at: starch, oxygen, glucose. Okay, so we're not even worried about protein or amino acids, right? So we want to look at this carefully, look at these test results. And then a V. Mystery, A. Kim, and R. Frost. All right, if I look at R. Frost, in the mouth, normal starch, normal oxygen, normal glucose. Okay, in the small intestine, we have normal starch, no oxygen. Okay, that makes sense. Should not be any oxygen in the small intestine, not in the digestive system. I know that. Glucose molecules low. Okay, maybe something to be suspicious of, maybe not. Lungs, no starch, no glucose, and oxygen. Okay, little suspicious of R. Frost, but not sure. I'm going to keep reading. A. Kim, in the mouth, we've got normal starch, normal oxygen, low glucose. Okay. Oh, that was different. So I'm seeing a difference here, so I'm going to make a note of that. R-Frost is different than AKIM for the mouth glucose levels. Small intestine, right? We have in AKIM normal starch molecules, no oxygen, that's normal. Glucose molecules low, okay? And in the lungs, no starch, oxygen molecules, no glucose. Okay, looks good. We're going to look at V Mystery. In the mouth, normal starch, low oxygen. Okay, that's different. Low glucose. Small intestine, normal starch, no oxygen. That's good. Glucose molecules normal. Okay. And in the lungs, no starch, oxygen normal, glucose molecules none. Okay, so when I'm looking through this, I'm noticing all the oxygens, they're all the same. So I can just ignore. Oh, wait, no, they're different. Mouth, there's low oxygen in V Mystery. So I'm highlighting the differences. Now let's look at the question. The tables above show information about the body systems with 3 different patients. Which of these patients' bodies are not working well enough to exercise normally? Oh, boy. This is a lot. So let's go back up. We got R-Frost only, V Mystery only, R-Frost and AKIM, AKIM and V Mystery. So if we look, I noticed that V Mystery has low levels of oxygen in the mouth, which is, but normal levels of oxygen in the lungs. So that seems okay if there's low oxygen in the mouth and normal in the lungs. Well, I got to check with Ms. White if that's okay. All right, I'm back. Second for you. It's like 5 minutes for me. It's my first time doing a recorded video, so I'm a little nervous. Thank you for going on this journey with me. So, back to the question. I reread the question because I got confused. The table above shows information about body systems with 3 different patients. Which of these patients' bodies are not working well enough to exercise normally? Exercise normally. So I'm only worried about glucose and oxygen. I'm not even worried about starch. Oxygen levels for V Mystery. Oxygen levels in the mouth, kind of low. Maybe she's taking, or he's making small breaths. Then small intestine, none. Lungs, normal. We're good. V Mystery has normal levels of glucose in the small intestine. Good. This V Mystery can exercise normally. AKIM. I'm just going to look at lungs, oxygen molecules normal. Glucose molecules low in the small intestine. Might not be able to get those glucose molecules to the cells. So this person might not be able to, is not going to be able to exercise normally. R-Frost, oxygen molecules, normal in the lungs, great. Glucose molecules low in the small intestine, normal in the mouth, but we know that the glucose is not absorbed in the mouth, it's in the small intestine. So R-Frost, AKIM are going to be not able to exercise normally. So scientists, don't get freaked out about these questions, right? Reread the question, go back. What do we know? What can we eliminate? All right, so that was a brief overview of Metabolism Standard 2. Systems in the body work together to take in, break down, and deliver needed molecules to the cell.